We've taken a look at our block size 16, block size 32, block size 64, and I actually gave you a little hint in the block size 128, but all in the fourth octet. What if we move it over to the third octet? What if we have a value in there? So we should take a look at a block size 8, block size 4, and then maybe look at putting that into the third octet to see what happens. All right, so let me put my block size formula back up here for us. So 256 minus funky is block size. So let's take a look at a block size 4, because if you look at the chart, the block size columns that we've developed so far, we have 16, 32, and 64 written up here. What if I had a block size of 8? What if I had a block size of 4? Well, I already have 16 entries for my block size 16. Do you think it's really worthwhile to go 0, 8, 16, 24, 32, 40, 48, 56, 64, 72, 8? No, that's too many numbers. So for my block size, again over here on my right hand side I guess, for a block size 8 or a block size 4, maybe we want to generate them just in time. Really? So now I'm going to do math, we're going to do binary? No, no, no. But if I know, and I can tell you for a fact that every number in the block size 8 and the block size 4 column are also in the block size 16 column, then if you gave me an address, again, if we go back to what we had before, 200.200.5.100, and I say slash 29 instead. 29 up here was my block size 8. So where's 100? I don't want to go 8, 16, I don't want to do that. But I can find out where 100 is in my column over here, and 100 is after 96. So I know that 96 is going to be in my block size 8 column. I got to add 8 to this, which is 104, and add 8 to that, which is 112. And what you see is I've got the two little pieces. Now I've just extracted a little short piece of my block size 4. I'm sorry, block size 8. So now where's 100? It's after 96. What's the broadcast address for 96? 1 less than 104? 103. Valid range of addresses, 97 through 102. Again, it works exactly the same as we did for block size 16, block size 64, block size 32, block size, we did 128 as well. What if I go out here and get a little crazy? I know this is crazy talk, but if I change this to 30. 30 is a block size of 4. Again, how am I going to do that? I don't have a block size 4, and I don't have to. Again, 96. 96 is after 100. So 96 plus 4 is 100. Plus 4 is 104. Plus 4 is 108. Plus 4 is 112. Again, there we go. 96 to 112, that's the little piece that I've extracted of block size 4. And now I can see that 100 is on the 100 network with a broadcast address of 103. Valid range of addresses is 101 through 102. You see the problem here? If this address 100 was actually assigned to an interface, to a PC, to whatever, it wouldn't work. This is invalid. It is the network ID. Cannot use it. Again, knowing my network, first, last, and broadcast tells me all of that information. What if we were to bring this into the third octet instead? So what if I were to say, let me reverse my numbers. I'm going to use the same numbers, but I'm going to do 200.200.100.5/30. What I want, nope, not /30. What I want to do is bring it into the second octet. I want to bring it into the second octet with a /22. Oh my God, what 22? How does that work? What's going on with 22? It's 22 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So this is 252 in the third octet. $252 in the third octet, 252, 256 is block size 4. It's a block size of 4 in the third octet. What does that mean? that means that this is on, well, where's 100? Hey, look, we got the same numbers over here. This will still work for us. Where's 100? It's right here. So my network ID is 200.200.100. It's got to be 0. Oh, so what's the broadcast address? Well, what was the broadcast for 100? 103? So it's 200.200.103. Ponder, ponder, ponder. The broadcast address is all ones, 255. What's my valid range of addresses? 200.200.100.1 through 200.200.103.254. 100.1, 100.100, 100.200, 100.255, okay? Yep. 100.255, that's an okay address. It's in the middle of the range. 101.0, sure, these are all okay, fine, perfect, yep, okay, got it, no problem. 101.200, 101.255, sure. 103.0, sure. They're all, wow, how many addresses is that? Well, it turns out that that's 1,022 addresses, which would be 1,024 total. How does that work? Well, the number of addresses we have are 2 raised to the total number of zeros. I have 10 zeros, 2 to the 10th, that's 1024. Can't use the first and the last, that's 1022. So even in the third octet, even in the second octet, the block size still works. You just have to remember that everything to the right is zeros, everything to the left is ones. So subnetting in your third octet, just as easy as subnetting in the fourth octet.